Alright, for this problem, we have f of x, our function, equal to x cubed. And I want to look to see what happens at f at 4 plus h minus f at 4 minus f at 4 over h. What happens to that when h equals 0.1? Well, if I take this, I do this calculation, that's the same thing as saying f at 4.1 minus f at 4 over 0.1. And if I go 4.1 cubed minus 4 cubed over 0.1, I end up with a value of 48.921. And well, what this is calculating though is, let's consider this. Consider I have a function. Here's my x and y axis. If I take my function, and it's going to be something here. Here is 4. And it has this value here of f at 4. And if I take another line, let's take a green line, and I add 0.1 to it. So that distance is 0.1, making this 4.1. If I go up here, and then over to here, I have f at 4.1. And if I do the change in y, which is this is the change in y, over the change in x, which is 0.1, I get the slope of this red secant line. Now, and this particular slope is 48.9. If I take this point, though, that is here, and the second part of my question is going to be, what happens to this calculation, f at 4 plus h minus f at 4 over h? What happens as h goes to 0? Well, that means this distance here, this is going to start to go in towards 4. This point's going to go this way, and it's going to be approaching what we call the tangent line, which we know is the derivative. So this is an estimation of the derivative. If I take h going close to 0, that means I want to find the derivative at 4. So this particular calculation here is saying f prime at 4 equals what? And so, well, f prime of x equals 3x squared. And so if I find f prime at 4, I get 3 to the 4th squared, which is 48 exactly. And so the question is asking us about the first principles of a derivative, where it actually comes from, this idea of the secant value. As this point gets closer to this point, we get the derivative, the slope, and that slope is the tangent. And this is the slope happens when h goes towards 0.